solving one-step equations. Well, one-step equations, that means, what is an equation? Equation is something that is equal. That means one side is going to equal to the other side. That's what equation means. It's like a scale, right? Which always has to be imbalanced. Now, before we go to one-step equations, let's look about combining like terms. What does that mean? If you look at this example, this problem in here, it says 6a plus 3 minus 2a plus 2. Well, we want to combine terms that are alike. So 6a, well, what is it like with? It's alike with the minus 2a, right? And then we have positive 3 that is alike with the positive 2. Basically 3 and 2, they do not have variables, so they belong together. Just like the 6a belongs with the minus 2a. Well, we're going to solve that. What is 6a minus 2a? It's 4a, right? And now we're going to combine the positive 3 with the positive 2. If I add 3 plus 2, I will get positive 5, right? So let's add that up. And now we're going to look at this problem, and can we do anything else with it? Can 4a be combined with the number 5? Not really. That is really it. 4a has a variable, it's basically 4a's, right? And then I have a number 5. They do not belong together, so there is nothing else I can do about it. Next example, I have a number 2, and that number 2 is multiplying everything that's inside that parenthesis. And what is inside the parenthesis is x plus 2, and then we have minus 3. The 2 is going to multiply the x, and 2 is going to multiply the 2. Well, 2 times x is 2x, right? I want you to keep in mind, multiplication can be a little ninja. If you don't see it in there, it means a multiply. 2 times 2 is 4, and then we have a minus 3. Let's combine our like terms, right? What can we combine? Well, the positive 4 with the minus 3. Now, is there anything we can combine the 2x with? Nope. That's the only variable there is, right? So it's still 2x, right? And then we have 4 minus 3. And what is 4 minus 3? Positive 1. Can we combine the 2x with the positive 1? No, we cannot. One has a variable, the other does not. So we are done. That is it. Now that we reviewed, now that we have kind of looked at combining like terms, let's look at this example in here. X plus 3 equals 15. Well, we have to look what can we combine. What can we combine? Well, that 3 can be combined with the 15, right? And the x in here, there's nothing I can do with. It's all alone and it wants to stay alone. We're going to be putting it in a little bubble because that means isolate it. Keep it alone. Don't touch it. So we're going to move the positive 3 from one side of the equal sign to the other side of the equal sign because the 3 wants to get away from the x. To move something from one side to the other, we have to do the opposite of what it is. All right? Well, positive 3, we want it to be a 0. Well, how do I make plus 3 to be a 0? Well, there's only one way. I have to subtract the 3. Now, because it's an equation, it always wants to be in balance. So what I do on one side, I have to do on the other side of the equal sign, a balance scale, right? Now let's see what we're left with. The x. We did not touch the x, right? So the x is still there. So we'll drop it down. Now positive 3 minus 3 is, well, a 0, right? And that's what we wanted. We wanted the 3 to be gone from the left side, right? Away from the x. Then we have our equal sign. And on the other side, we have 15 minus 3, which equals 12. So our solution is x equals 12. Now, just to make sure we are correct, we're going to do a check. We are going to rewrite the original equation, and we're going to substitute in the x, right? So let's substitute in, let's rewrite it, and see what we got. The original equation said x plus 3 equals 15. We've said that x is equal to 12. So everywhere I see x in the original equation, I will substitute in the 12. Basically replace with the x with what it's supposed to equal to, right? So let's substitute in. So we have 12, which was the x, plus 3 equals 15. And now if we solved correctly, both sides of the equal sign will equal. Well, 12 plus 3 equals 15, which it does equal 15. So our answer checked. So x indeed did equal to positive 12. Sounds good? Now let's look at the next example that is waiting for us. The next example on the next side, has fractions. Well, let's see what we can do. It says a plus 3/4 equals 5/4. First step is isolate the variable. Isolate the a because that is telling me don't touch it, leave it alone. On that same side, there is positive 3/4. And the positive 3/4 wants to be with the positive 5/4, right? They're like terms, so they want to be together. And the a says, I want to be here all by myself. So I'm going to take the 3/4 and move it. Now, the 3/4 wants to be a 0 on the left side, right? It doesn't want to be there, so it has to become a 0. So how do I make 3/4 to be 0? Well, subtract the 3/4, right? The opposite of what I see. So it was plus 3/4 minus 3/4. What do I do on one side? I have to do also on the other side of the equal sign. Remember, it's an equation, so it has to be imbalanced at all times. We did not touch the a, right? So the a is going to kind of drop down. So the a we're going to rewrite. And then we have positive 3/4 minus 3/4. Well, it's the same number, opposite signs, right? And the same number with opposite sign will cancel itself out, right? It will become a 0. So 3/4 minus 3/4 is a 0, and that is what we wanted for it to be gone, right, from that left side. We have equal sign, and then we have 5/4 minus 3/4. Now, how do we add and subtract equations? Well, the most important thing when it comes to adding and subtracting fractions is to have a common denominator. Common denominator, you remember, that's the bottom number, right, and the fractions. Well, in this case, we do have it. Both are 4. So we're very happy because they both have 4. And the only thing we're going to do is subtract the 5 and the 3, the numerators. So we have a equals 5 minus 3 over 4. Now, what is that equal to? Well, a is going to equal 5 minus 3 is 2 over 4. Now, if you think about it, 2 and 4, they're both even numbers. They both can be divided by 2. So let's divide both of them by 2. We're going to simplify. And 2 divided by 2 is 1, and 4 divided by 2 is 2. And that is our final answer. A is equal to 1 over 2, or 1/2, right? Now, after we are done, we want to make sure that we are correct, that our solution indeed is correct. Well, the only way to do that is to make a little check, right? We want to make sure that A indeed is 1/2. And if it is, if I substitute it into the original equation, I should have both sides that will equal to each other. So we have A plus 3/4 equals 5/4. 1/2. So in the original equation, everywhere I see A, I will replace it. I will substitute in the 1/2 and solve it and see if we are correct. So let's do that. 1/2 plus 3/4 equals 5/4. Well, let's see. Well, I have a little problem with this because if you look, the denominators are not alike, right? When we're adding or subtracting fractions, the denominators have to be the same, and they are not. One is 2 and one is 4. So let's change the smaller one and make it look like the other one. Make the 2 be 4. Well, the only way to make 2 to be 4, I have to multiply it by 2, right? And when you multiply something by 2 in a fraction, if you multiply the denominator, you also have to multiply the numerator, right? That's why it's always going to stay kind of equal to each other. So 1 times 2 is 2, 2 times 2 is 4, plus 3/4 equals 5/4. Now we have a common denominator, both are 4 on the left-hand side, so we can only add the numerators. And 2 plus 3 is 5. We have our denominator as 4. So if we do that, and 5/4 does equal 5/4, right? So our solution to this problem checks. We solved it correctly. So we are winning so far when it comes to solving one-step equations. Now, let's see what we've got next. So far we were just taken away, right? Because when we had addition, we had to do the opposite, which was subtraction. In this example, we have a minus 5 equals 16. So we're going to isolate our variable, and we see that the minus 5, the minus kind of belongs to the 5, wants to be with the 16. And now they're on the opposite side of the equal sign. So the minus 5 wants to say, is saying, hey, please get me away from the variable a. Variable a wants to be alone, and I want to be with you, 16. Well, the only way to make minus 5 or the negative 5 to be gone from that side is by adding it, right? We're going to do the opposite of what we see. And if I add something on this side, I have to make sure I add it on the other side of the equal sign. And let's see what we've got. We still have the a, so a drops down. Now, minus 5 plus 5, same numbers, opposite signs, it will become a 0, right? Then we have our equal sign. And on the other side, we have 16 plus 5, which is 21. So our solution is a equals 21. Now, do you believe me? Well, I believe it, but I want to see it. Let's rewrite the original equation that says a minus 5 equals 16. And we have said that a is equal to 21. Well, let's make sure it is. Everywhere I see in the original equation a, I am going to substitute it with the number 21. So let's do that. We have 21 for a minus 5 equals 16. And 21 minus 5 indeed does equal 16, and 16 does equal 16. So guess what? We've checked, right? We have solved this problem. Both sides equal to each other. Yay! Good job, guys.